For part B, we're going to do the same thing again. We're going to differentiate this. This time we need to use the product rule. We've got an e to the mx times by x squared plus mx. So the product rule says to differentiate the first one, e to the mx, and when we differentiate that we get e to the mx again, but we need to times by m, so we get me to the mx. Leave the second one alone, plus leave the first one alone, and differentiate the second one. When we differentiate the second one we get 2x plus m. So we want that to equal 0. And if we expand the brackets, we'll get mx squared e to the mx plus m squared x e to the mx plus 2x e to the mx plus m e to the mx. They all have an m e to the mx term in them, so if I factor that out, then we get x squared plus mx plus 2. Oh, this one's not got an m term in it, that doesn't matter. They both have an e to the mx term in them, so if I factor that out, I'll get mx squared plus m squared x plus 2x plus m equals 0. I've got a product here, I've got this times by this equal to 0, so either e to the mx equals 0 or mx squared plus m squared x plus 2x plus m equals 0. Now, an e to the mx graph will never equal 0. We'll get that. So there's no stationary points from here. However, this is essentially a quadratic. And to find the number of solutions in this, we can look at the discriminant. We don't need to solve the whole thing, we can just look at the discriminant. So the discriminant is b squared minus 4ac. And if that will always be positive, then we'll have 2 stationary points for any value of m. So b squared minus 4ac is going to be m squared plus 2 squared minus 4 times m times m. If I expand this, I'll get m to the power of 4 plus 4m squared plus 4. Take away 4m squared. As you can see there, that's going to be 4m squared. The 2 4m squared terms cancel, and I'm left with m to the power of 4 plus 4. M to the power of 4 will always be positive. Its graph looks like this. That's never negative. So if we add on 4, this will always be positive for any value of m. So because it's positive for any value of m, That means the discriminant is positive for any value of m, which means there will always be 2 stationary points for all values of m.